Okay, we're going to jump into lesson 7.3, which is graphing linear inequalities. And we're going to start by just looking at an example here. When we're graphing these linear inequalities, it's really important to remember that this is really similar to graphing lines, especially if we have things in slope-intercept form. You're going to use the slope and the y-intercept to graph these, but then there's just a couple of things that we need to pay attention to, a couple of details that we don't have with our linear equations that we will have with the linear inequalities. And so it says that right here, it says arrange the inequality into slope-intercept form, right? So we're going to try to get these into slope-intercept form and then use the slope and the y-intercept to graph. Pay attention to the type of line and the shading. So those are the two things we're going to talk about right now. If you were to look at this example, you would see we do have this shading, right? This yellow shading underneath the line that they've drawn here. Okay, and so let's talk about the type of line and the shading here. So first, if we have a less than symbol or a greater than symbol, right? So there's no or equal to bar underneath, then this is going to be a dotted line that we're going to draw with our graph. Okay. And what I mean by that, instead of drawing this solid line that they've drawn here, right, like we normally would, you would draw a dashed line or a dotted line here to show that any point on that line is not included in the solution set. And we'll get to that in a second. If we have a less than or equal to or a greater than or equal to, then we just draw a normal solid line. Okay. So the difference here is that one of these has the or equal to bars, that's a solid line, and down here, no or equal to bars, that's a dotted line. Okay. And then the next part is where to shade, because you can see that there's going to be some shading, and remember that's because our inequalities have groups of solutions, whereas our equations normally just have one solution, or it's not as big of a group, so we don't need the shading there. Okay, so if we have a greater than or equal to sign, then we'll shade above, right, because we want bigger numbers, numbers that are greater. And if we have less than or equal to, that'll be a shade below, because we want numbers that are less, that are lower, so we would shade below, and those would be our solutions. And then the last thing it says here is that the solutions are all the xy ordered pairs in the shaded area or on a solid line. So if I pick a point from my example here that's in the shaded area, like let's say this point right here, which is 1, -2, that is a solution to this inequality because it's in this shaded area, and if I plugged it into my inequality for x and y, I'd get a true statement. And because this is a solid line, I can also pick points that are on the line, and those would also be solutions here, right? Any of these points that are on the line, they would also be solutions. Were this a dotted line, that would not be the case. All right, let's graph a couple ourselves here. Okay, the first one is already in slope-intercept form. We can see that it's y is greater than 2/3 x minus 4. Remember our b value, our y-intercept, okay, is back here is the -4. So I'm going to go to -4, 1, 2, 3, and -4. And then I'm going to use the slope, which is 2/3. Remember, that's rise over run. So up 2, and then to the right 1, 2, and 3. And I can keep doing that if I want. Right, up 2 over 3. And we end up with this line. But we need to pay attention. Okay, is this going to be a solid line or a dotted line? In this case, there's no or equal to bar there. So this is a dashed line or a dotted line. So we'll go ahead and make this line just like we normally would, except it's going to be dotted. And then the other part we have to pay attention to is the shading. So in this case, we have a greater than symbol. So we want numbers that are bigger, in this case on top of the line, right? The bigger numbers are on top of the line. So that's going to be everything in this area here, right? Anything on top of the line. So all the points in this area would be considered my solutions. I'll fill this in here. All right. So then it asks me down below which of these points are solutions. So 0, 0 we can see is in the solution set, so that's a check mark, yes. -2 Positive 8 is somewhere up here, so that's a check mark, yes. And then we go to 4, negative 7, 1, 2, 3, 4, and negative 7 is going to be somewhere down there, so that will not work. And then 3, negative 6, negative 3, 1, 2, 3, and negative 6. So this point ends up right on our line, but since it's a dotted line, this does not count as a solution. It only counts on solid lines. All right, we'll move to the next one here. Same idea, we've got the b value at positive 1. Okay. And then we've got the slope as 2, which is the same as 2 over 1. I like to write it as a fraction because I'm going to go up 2 and then to the right 1. Okay. And so this will give us our points. Now we have to decide, okay, is this a solid line or a dotted line? Well, this has the or equal to bar there, right? So this is going to be a normal solid line. And now we have to decide what's the shading going to be for this line. So this is y is less than, right? So we want numbers that are less than this. Okay, so I'm going to go ahead and shade everything that's below this line. Let's try that again. So everything in here. Okay. And so then we have to decide which of these points are solutions. So 0, 0 we can see is in the shaded area, so that's a check. Negative 2, comma 8 is somewhere up in this second quadrant, so that's not going to work. 4, negative 7 should be down here, so that is a solution. And then 1, comma 3, this one is right on the line, but since this is a solid line, this counts as a solution. All right, moving to letter C here. Notice this one is not in slope-intercept form, so I'm going to go ahead and rearrange it to get y by itself. That means I just subtract 3x from both sides. And I end up with this inequality y is less than negative 3x plus 6. And so then my y-intercept is at positive 6. Right there. And then my slope is negative 3 over 1, so that's down 3 and to the right 1. Okay, and so I end up with my points. Now I have to decide, okay, is this a solid line or a dotted line? This is a less than symbol. It does not have the or equal to bar, so that just means it's going to be a dashed line here or a dotted line. And then the last piece is to decide which way to shade. Since this is a less than symbol, we want the numbers that are lower, right? If you can't tell, imagine that this is a tree. This line is a tree. Which way would it fall? Well, it would fall down that way, right? So that must be the lower numbers. So we want everything in that area, everything that's less than this line here. Okay, so all this space in here. And now we got to figure out our solutions. So 0, 0, that does count. Okay, negative 2, comma 8. Well, that's just barely going to fit in there, right? I think it's right about here, so that does count. Okay, and then we keep going. 4, negative 7. Okay, so 4 and then negative 7. I think that does fall in, so that's going to work. And then negative 1, okay, somewhere right there, so that works as well. And of course, there's many more solutions, right? Like any of these points here that they didn't list are solutions as well. They're just trying to get you to determine if those 4 are solutions. All right, we'll keep going here. Okay, it says Kevin is buying movie tickets for his family. Adult tickets cost $8 and child tickets cost $2. Kevin wants to spend no more than $48 on tickets. How many tickets of each kind can he buy? Let X be the number of adult tickets purchased and Y is the number of child tickets purchased. So they've already defined our variables for us, right? X is going to be the adult tickets, and over here we've got Y is the child tickets. And we're going to go ahead and set up an equation similar to how we have done in the past. So it's $8 for each adult ticket, and remember X is the adult ticket, so I'm going to say 8X plus, let's see, we've got $2 for the child ticket, so that's going to be 2Y, and he wants to spend no more than $48, right? So we're going to be less than or equal to $48 because Kevin can spend under $48, right, or equal to $48, but not greater than. So this is a less than or equal to $48. Okay, now it's going to ask me to graph this inequality, and so I can do that using the x and y intercept as we've done in the past, right? So my x-intercept, try to find some space here. Okay, so my x-intercept equation would be 8x, okay, and I'm just going to set it equal to 48 for the solving purposes. I know that it's a less than symbol there, but for solving we can set it equal to. Divide both sides by 8, and we end up with x equals 6. And then for the y-intercept, we're going to end up with 2y equals 48, and divide both sides by 2, and I get y equals 24. Okay, and so I have these intercepts at 24 and at 6, okay, and so I'm going to go ahead and put these onto the graph here. So for the x-intercepts, right, that's the adult tickets, I can just go ahead and count by ones there, 1, 2, 3, 4, 5, and 6. Okay. And then for the y-intercept here, it's at positive 24. Okay, so I'm going to count by 3s. 3, 6, 9, 12, 15, 18, 21, and 24. Okay, so I've got my 2 points there. All right, we can see that this has the or equal to bar there, right? So I'm going to make a solid line. And it's going to look just like that, solid line. And then since it's a y is less than, notice it's y is less than, right? We want to shade below this. We also know that he does not want to go over 48, so we're going to keep that below the line. So my shading should be everything that's in this area here. Okay, so all my solutions will end up in that area. It says make a table of values that shows at least 3 possible solutions to your inequality. So this is anything in my solution set, right? So I just need to pick out 3 points here. So if I take this point right here, that would be 1 adult ticket and 12 child tickets. So I'm going to say 1 adult and 12 child. Okay, and I can pick out any other combination that's in here. Right, so maybe this one here, this would be 3, 6. So 3 adult and 6 child. And I'll let you pick out the last one, anything in that shaded area. Okay, it says plot those points. We just did that, right? I already did that. It says, how do you know that these points are solutions to your inequality? And we can say because it's in the shaded area. Say in the shaded solution area. And of course, you could go back and test these. You could plug these in for X and for Y and make sure that you ended up with true statements there, but that would prove that they are solutions. Okay, we'll go down to example 3. It says write the inequality for the given graph. So this time they've given me a picture. I need to go ahead and write the inequality here. So I need to know what the slope is, and I need to know what the y-intercept is, and if I have those 2 pieces, then I am good to go. So let's take a look here. First, I'm going to find the y-intercept, which is right here. Let me do this instead, where it intersects the y-axis, so it looks like that's at 9. And now I'm going to figure out what the slope is, and I think it's easiest to find the slope if you use 2 points where they hit evenly on the grids here. So I know that one hits evenly on a grid, on a nice grid point there, and then maybe this one over here hits a nice grid point, but you can take any 2 points on that line, and it looks like we're going down 2, 4, 6, 8, 10, so that's down 10. So for my rise, I have negative 10. And then I'm going to go over 2, 4, 6, and 8, and over 8. And I could reduce this to negative 5 over 4. And so I end up here with my equation looking like this. Y, I have negative 5 over 4 x, and then a plus 9 for the y-intercept. Notice I did not draw the symbol yet. Okay, for this one, we are shading above my line, right? We're shading above this line. So I know that it's got to be a y is greater than, and we have a solid line, so then I'm going to add the or equal to bar. And we are good to go there. Okay, if we go down to letter B, same idea. I'm going to first start by finding the y-intercept, which is right there at 4, so that's my B value. And then I'm going to go ahead and find an even grid point. How about that one right there? And find the slope. So it looks like we're going down 2, 4, 6, and 8, down 8. So that's m equals negative 8. And then to the right, 2 over 2, which is the same as negative 4. So I have y negative 4x plus 4 for my y-intercept. And again, I got to come up with this symbol here. For this one, we're shading below the line, right? Because this line would fall down this way. We're shading below the line, so it's going to be y is less than, and it's a dotted line, so I'm not going to add the or equal to bar there, and we are done with that one. And the last one here, it says, write a linear inequality to represent this given information. Shanley would like to give a $5 gift cards and $4 teddy bears as party favors, and Shanley has $132 to spend on party favors. Enter an inequality of the number of gift cards and teddy bears Shanley could purchase. Give one solution to the inequality. Okay, so for this one, we're going to assume that this person can't go over 132. It says use X for the teddy bears. X is the teddy bears. So let's see. It is $4 for the teddy bears, right? So that's going to be 4x plus $5 for the gift card, so that's 5y, and this needs to be less than or equal to 132. Okay, and so that would be the inequality there, right? And you could come up with different solutions. You could just try them in x and y here and make sure that they are less than 132. You could also graph them and see if they turned out in the solution set. So if we just pick two numbers, right, if we were using guess and check here, we could do that, right? So if I just said, okay, well, let's say that this person does 1 teddy bear plus 3 gift cards. Is that less than or equal to 132? I have a really good feeling it's going to be. So this would be 4 plus 15 is less than or equal to 132. Now it would just be 19 is less than or equal to 132. And that's a true statement, right? 19. So then that means that this would work as a solution. 1 teddy bear and 3 gift cards. And of course, Shanley would be keeping a lot of money for themselves here if they just bought 1 teddy bear and 3 gift cards. All right, thanks for watching.